All right, hi everybody. We're going to be learning about square roots and irrational numbers in this section. All right, so let's get started. Let's take a look at this square. All right, let's pretend the square has a side that has a value of 1 unit. All right, well, we know that the area of this guy would just be 1 times 1, which is 1 square unit. Now let's look at something that is twice as large, all right, in terms of the one side. So the interesting thing is if the side is doubled, all right, that means that we've got 2 units this way and 2 units this way. So how many square units would that be? Or what is the area? The area would be 4 square units, right? So a square that we would say is twice as large has an area that's 4 times as large. That's interesting. And now let's look at a square that is 3 times as large as the first one. All right, so the side is going to be worth 3. So 3 units this way, 3 rows, and then we've got 3 columns. What would the area be? That would be 9 square units. So you can see the area increases a lot faster than just the length of the side. All right, so these square units are called perfect squares. We look at them and we say 1 squared would have an area of 1, 2 squared would have a value of 4, 3 squared would have a value of 9, and so on. And all these numbers that are squared, this is the area, and the area is called perfect squares because they're the area of whole numbered sides. All right? So we're going to use that chart to help us out in this next section here. All right, and again, there we go. They're called perfect squares. Okay, now, perfect squares. We're going to go backwards, and we're going to say, well, what the heck are these things? These things are called the square root symbols, right? This is the opposite. This is going backwards. So I'm going to go back to that last page. I'm going to say, let's check this out. If I actually wanted to go, instead of going from here to here, instead of going from here to here, let's imagine I was going backwards and going from this whole number, the area, back to what would the side length be? All right, I would take the square root. The square root of 1, I'm basically asking myself, what times itself is 1? And that's 1. What times itself is 4? It's 2. And what times itself is 9? It's 3. So we could go back and think about equations and say, what's the opposite of multiplying? We'd say dividing, right? And we'd say, what's the opposite of adding? We'd say subtracting. We always do the opposite operation to isolate the variable. Remember doing that? Well, in this case, the opposite of squaring a number, something that we're familiar with doing, the opposite of squaring a number is taking the square root of a number. All right, so I could go down and say, what is the square root of 64? In other words, what times itself is 64? And that would be 8, right? Okay, so let's look at this chart. This is just here to help you. Okay, these are called the perfect squares, right? The numbers over here because I get whole numbers. Those are the lengths of the sides of the square. So here's some example problems. Let's look at example problem number 1. Simplify the square roots. Well, what is the square root of 49? I want to know what times itself is 49. And I could look at my chart over here and I could say, oh, geez, it's 7. That was easy. All right. This one's saying, what is the opposite of the square root of 81? So what times itself is 81? We'd say 9, right? And then what is the opposite of that? It would just be negative 9. Because remember, that negative there is the same thing as the word opposite. And that helps you remember why we do that. All right, this fraction is a little bit curious. This is the same thing as doing the square root of 16 over the square root of 25. It's the same thing as doing 2 separate problems. So I'm basically asking myself, what times itself is 16? I look over at my chart, and I could say, oh yeah, 4. And what times itself is 25? That's 5. So the answer would be 4/5. All right, let's look at the second types of problems. Example problems number 2, they're going to ask you to estimate to the nearest integer or whole number. Okay, so the square root of 59, that looks funny because I'm asking myself, what times itself is 59? And I could say, well, I know that 7 times 7 is 49, right? And I know 8 times 8 is 64. And I know 59 is somewhere between 49 and 64, right? The question is 59 closer to 49 or is it closer to 64? All right, well, it is 10 away from this guy, and it is only 5 away from this guy. So because it's closer to the square root of 64, I know that the square root of 64 is 8. I would estimate that, and I'd say it's around 8. It's closer to 8 than 7, right? All right, next one. Opposite of the square root of 84. So I know my answer is going to be negative. I know that. All right. And I want to know, where does the square root of 84 fall in between? I could put it right in here, right? I could say that the square root of 84 falls in between these two guys. Yep. So square root of 84 is somewhere in there. Is the square root of 84 closer to the square root of 81 or the square root of 100? All right. I know 9 times 9 is 81. I know 10 times 10 is 100. But it's definitely closer to 9 than 10 because it's only 3 away here, right, as opposed to 16 away here. So my answer would be approximately -9. And the last question, the square root of 20. Hopefully you're getting better now and you're understanding. Square root of 20, what times itself is 20? Well, I know 4 times 4 is 16, right? Whoops. 4 times 4 is 16, so that would be 4. And I know 5 times 5 would be 25. So it's definitely closer to 16. It's only 4 away as opposed to 5 here. So my answer would be approximately 4. Although it's pretty close to being 4.5, somewhere in the middle, but it's going to be closer to 4, okay, than 5. Okay, next section. We're going to talk about this word, rational number. You've seen this in the past. And basically, a rational number is any number that can be written as a fraction. And here are some examples. You've got 4. Can I write 4 as a fraction? And the answer is yes. 4 over 1. There's your fraction. 2 3/4. Well, that's not a fraction. That's a mixed number, right? But I can write it as a fraction. 2 times 4 is 8. Plus 3 is 11/4. There's my fraction. And -6.3, right? We did a lot of conversion charts, converting between fractions, decimals, and percents. And we could definitely write that as a fraction, right? So I could say -6 3/10. And then I could just do what I did over here. Just make it into an improper fraction. 6 times 10 is 60, plus 3 is 63/10. And there's your rational number. It can be written as a fraction. This guy, your new one, right? The square root of 16. What times itself is 16? It is 4, and 4 can be written as a fraction. I just put it over 1. So any perfect square is a rational number. How about this guy, 5.4 with the repeating over the 4? You might have been taught that, you learned it from me, right? That anything that repeats is over 9. So 5 and 4, it's not 4/10, even though the 4 is in the tens place. If it repeats, it's over 9. So 5 and 4/9, okay? And that could be written as 49/9 if I make it improper. Okay, now the question is, what is an irrational number? It's a number that can't be written as a fraction. Well, what kind of number cannot be written as a fraction? That's a little bit hard to think about, but there's one definitely that you know. It is pi. Okay, pi is that number that most people would say it's 3.14, and they can recite pi off to an actually infinite amount of places, right? It goes on forever without repeating, and that's what makes it an irrational number. It's kind of funny though, because pi, some people know that as circumference divided by the diameter. And you say, well, that's a fraction. How come it's not a rational number? That's a good question, but just know that pi goes on forever without repeating, so it's irrational, okay? The square root of 19, if we take a look at this guy, I'm going to ask myself, what times itself is 19? Well, I know 4 times 4 is 16, and I know 5 times 5 is 25, so it's somewhere between 4 and 5, and it's closer to 16, so it's going to be closer to 4. So my answer is going to be 4 point something. It's going to be closer to 4.5, but that number is actually going to go on forever without repeating. And if you do this on the calculator, you'd find out that it would take up the whole calculator screen, and there would be no pattern, and it wouldn't repeat. All right, and I'll do that here in a second. Another type of irrational number is just a number that has those dots after it, showing that it's going on forever, that it is not repeating, and that there is no pattern that you could write as a decimal, or as a fraction, I should say. All right, so irrational, you see the difference here. You've learned the difference between those two, and also we've looked at square roots. All right, so real quick, I'm going to show you the square root of 19, and you can do this at home if you don't have your calculator with you. Just go down to the search bar, and you might have it on your phone. Most phones have a calculator on them, but I'm just going to type in calc down here, and it should bring up the calculator. You see it up here, calculator. And it'll bring up a standard calculator on your computer. But there's a way to find the scientific calculator right here, scientific. And this is a little more advanced, right? You've got square root functions. I'll make it the whole screen. Let's see if I can find it. Where is the square root function? Maybe I'll just use my standard calculator. And okay, here it is. Okay, it's the opposite of squaring right here. And you might see a little 2 there. That's the same exact thing. Okay, so let's experiment. I don't know if I have to hit the button first. Yep, okay, so I hit the button. And I'm going to say the square root of 16. This is a test. All right, that didn't work. Let's do 16 square root. Yeah, there you go. Okay, so you hit 16, then the square root button equals, and there you go, 4. Now, let's go to 19. 19 square root button, bang. Look at that number right there. This number times itself is going to give you 19. All right. 4.358898943540674. And that's just as far as this goes. But that number actually goes on forever without repeating. And that's what makes it an irrational number. All right. So a little confusing, but pretty cool stuff. All right, guys. Hope you learned something, and we'll see you next time.